First of all, temperature conversions. I showed you these equations last time, so these aren't any different. The purpose is obviously to convert temperatures. I don't know why I put a purpose on there, but anyway. F is Fahrenheit, which I'm almost certain this is spelled wrong because Fahrenheit is spelled super goofy. No, it's the guy's name is Polish or German. I don't know. I forget what his nationality is. C is Celsius. And K is Kelvin.
Kelvin and Celsius, I can spell. Fahrenheit, forget.
Yeah.
I'll have the patience to learn.
All right. Yeah, there's a H in there. Yeah, the H is what I always forget. There's two H's. Foreign. Okay. All right, so number one, find the temperature in Celsius and Kelvin for 75 degrees Fahrenheit. So you're starting with Fahrenheit. So you're going to start by converting Fahrenheit into Celsius. Then you'll take that Celsius number and turn it into Kelvin.
I didn't get one.
Oh, you didn't get one? Get you one. So, 75 degrees Fahrenheit. Turn that into Celsius, turn that into Kelvin. The other one wants you to figure out what the temperature in Celsius and Fahrenheit is of 0 Kelvin. So you're going to start with Kelvin this time, turn it into Celsius, and then turn your Celsius into Fahrenheit. Okay? So pretty straightforward, nothing weird there. Let's go ahead and look at kinetic theory of gases. Now this is the one that's going to look scary, but I promise it's not. We've already talked about this. The way you figure out how much energy something has is how you figure out the temperature, right? The more energy something has, the higher the temperature is. And specifically, the type of energy is kinetic energy. So this is just the kinetic energy equation from last year, 1/2 mv squared. We add in how that relates to temperature, and the way it relates is 3/2 kT. So this is basically just to show how kinetic energy relates to temperature. So, what are all these things? Well, let's start with the easy ones, and then we'll work our way to the harder ones. So, V is velocity. Ke is kinetic energy. Capital T, not lowercase t, capital T is temperature. And K is Connor. K is called Boltzmann's constant because totally that begins with K. And the value is 1.38 times 10 to the negative 23rd. Yep. Yes.
Is there a calculator left on this test after yesterday?
I didn't see one.
You probably put it in his bed. To be fair, that was my own.
I didn't see one yesterday, so. Yes. Yeah, so let's talk about this equation. So how to use it. So here's how you use this equation. So ask yourself, what two things, wow, let's spell the word two right. Good job, me. What two things are in this problem? And there are three options: energy, motion / velocity, and temperature. So let's look at an example. I'm not going to work the way through the math because you guys are more than capable of solving the algebra, but I am going to help you with the setup. So let's go ahead and look at number 3. What is the velocity of a helium atom that has a temperature of 6,000 Kelvin? Okay. Ask yourself, what is this problem about? What is the velocity of a helium atom that has a temperature of 6,000 Kelvin? What two things are in this problem? Velocity and temperature. So what I do is, here's the full equation. Ke equals 1/2 mv squared equals 3/2 kt. What you do is you either mentally or physically, whichever you need, circle the two parts you need. Temperature and velocity. So what equation do I use? 1/2 mv squared equals 3/2 kt. And then I solve. Okay? One thing I forgot to mention, well, not forgot to mention, one thing I forgot to do, I forgot to give you a mass for number 5. You need a mass of an object for number 5. Go ahead and use the same mass from number 3. So use the mass of helium, since it's already given in the problem. So what temperature is an object if its particles are vibrating at 99 meters per second? Go ahead and use a mass of helium for this one.
So this temperature doesn't need to be in a specific type of...
Yes, it does need to be in Kelvin. Temperature does need to be in Kelvin, hence why I underlining and bolded 100 C. That has to be in Kelvin. Yep. But it's easy to get in Kelvin.
When you teach it, like with the T, just T equals temperature in Kelvin.
Yeah, T is temperature in Kelvin. Yep. You'll notice I did not give you a unit for Boltzmann's constant. There is a unit for Boltzmann's constant. It's really long and nasty. And so I'm not writing it down because it'll confuse you. The unit for Boltzmann's constant is meters squared kilograms over seconds squared Kelvin. So it's not important, so I left it off. Does anyone have any questions? Okay, I want you to go ahead and get started. I would suggest starting with number 3 to see if you're going to